Okay, so we're looking today at calculating the global maximum and minimum values. So we're learning intention is to gain the knowledge in calculating the global maximum and minimum values. We were successful by calculating, if you can calculate the absolute highest value, then that's going to be your global maximum. If we can calculate the absolute lowest value of your function, that's going to be your global minimum, but it has to be over a set given domain. Okay. If I have this function y equals x to the power 3 plus x plus 1, we want to find the global maximum and minimums over this domain. So if I differentiate that, I get 3x squared plus 1. And if I want to find any stationary points, I set it to be 0. The problem is if I set that to be 0, I get negative 1/3 equals x cubed, and I can't do the square root of that, so a stationary point doesn't occur. I know that this function looks something like that. Okay, so if I have x equals negative 1 and I plug it back into here, okay, I get negative 1 minus 1 plus 1, y equals to negative 1. And when I plug in when x equals 2, I'm going to get 2 cubed, which is 8 plus 2 is 10 plus 1 is 11. Okay, so we'll get this point here of negative 1, and a point up here which is 2 and 11. So the global minimum occurs at negative 1, and the global maximum occurs at 211. Alright, let's look at this one. We want to sketch this curve and we want to find the global maximum minimums and in the domain between 1 and 4. Okay, so I'm going to differentiate it first. And I'll differentiate it again. Okay. Using the first derivative, I forget factorizing that 3 out. Okay, so a stationary point occurs at x equals 2. So when x equals 2, y, plugging that in, so we get y equals 3. Okay, and when x equals to 2, putting it into the second derivative, so we get a point of inflection. And we can test by plugging in 3, so to the second derivative. So 6 lots of 3 minus 12, we get 6, so it's a positive. And we get 1, we get negative 6, so there is a change in concavity. So this one is less than 0. So that's great. So okay, so now I should be able to sketch it. So I want so I know there is this stationary point called occurs at x equals 2. When x equals 2, y equals 3. We can plug in some values just to make it nicer. So when x equals to 1, we get 1 cubed minus 6 lots of 1 plus 12 minus 5. So 1 minus 6 plus 12 minus 5, we get 2. And also when x equals 4, so 4 cubed, 6 lots of 4 squared, plus 12 lots of 4 minus 5. So my scale is really out now. Okay. And there's a point of inflection at x equals 2, and there's a change of concavity, so this would be concave down, and then this is going to be concaved up. So this point here is our global minimum, and here is our global maximum. So the global minimum occurs at 1, 2, and our global maximum occurs at 4, 11. Okay. Now we want to sketch this function f of x equals 2x over x squared plus 1, and we want to state the global maximum and minimums of the curve between -2 and 2. Okay, so the first derivative, and I'll let you guys do that yourselves, but the first derivative ended up being -2x squared plus 1 over x squared plus 1 all squared. And the second derivative ended up being 4x cubed over x squared plus 1 to the power of 3. Alright, some important values we're going to find out. I'll sort that out in a second. Okay, so I'll do that. So when looking at the two extremes, when x equals -2, we get y equal to being 2 lots of -2, -2 squared plus 1. We get -0.8. And when x equals 2, we get y equals to 0.8. Okay, so we want to find stationary points. So once again, I'm looking at the first derivative. I don't want the denominator to be 0, but I do want the numerator to be 0. So I get two values, x equals plus or minus 1 over root 2. All right, we can determine a nature by plugging that value into f of f double dash, the second derivative. Okay. By plugging this into the second derivative, I get -11.31 approximately. Here I get 0.419, and I've placed these two values here, the -2 and the 2, the extremes, and I get 256, negative and positive. So I notice that this is less than that, and this is higher than that. So if I was to just quickly sketch something, so this would be root 2 0.8, and this would be -2, -0.8. Okay, so if I wanted to find these values, plugging this back in to the original function, I get 2 lots of 1 over root 2 over 1 over root 2 squared plus 1, something like 0.942, and -0.942. So what happens is I get something that looks like that. Okay, just as a rough sketch. Okay, good luck.